Welcome back to CS 111. In this lecture, we're going to take a little bit of a look at the software development lifecycle, basically the process for going and creating software. We're going to talk a little bit about software engineering, and then we'll go through the actual process of going and creating new software. As we get started talking about the software development process, I think a good place for us to begin is by taking a look at the field known as software engineering. Now, my discussion here is by no means intended to be an in-depth look at software engineering. We're just going to touch on things briefly. WVU has an entire course, CS 230, that's devoted to software engineering, and we also offer an online master's program specifically in software engineering. So if this is a field that you are interested in, there's a lot more that you'll be able to see it in our CS curriculum here at WVU. But let's just go ahead and get started with a quick look at things. So when we go and write programs, generally there's some sort of purpose that we have in mind for the program. Even if it's something that we're going to code for fun, we want our program to go and do something. You know, we have some sort of idea of what it's intended to do. If we're going through and writing a program that is intended for a business application, we can be sure that there is something that it is specifically supposed to do. Our goal as we go and implement our software here is to make sure that it goes and completes all the tasks that are necessary for it to do whatever it is supposed to do, and that it goes and performs those tasks correctly so that we go and get accurate results. Now, we could just go and start coding things, and for smaller programming projects, a lot of times people do just start going and coding things. But going and taking kind of an off-the-cuff sort of ad hoc approach to implementing software has a big risk of encountering problems. You might forget to go and implement some stuff that you need to do to make sure that stuff actually works correctly. Maybe there's some functionality that you were intending to do that you just, overlook, or it becomes difficult to go and work it in later. Just going and starting and coding stuff is not really a good approach. Software engineering helps provide us with formalized tools to ensure that we can have a successful process for creating our software from the very beginning when we go and identify what our software is to do, to going and actually writing the code, to going and deploying our software. By going and having a formalized approach, and there are many within software engineering, we can really dramatically reduce the chance of running into problems that are going to prevent our software from working as intended or maybe even being completed at all. Within software engineering, there are a couple major goals that we're trying to go and address. The first one really starts at the very basic level here. As we begin to create a new program, it's to go and figure out what our program is supposed to go and do. So software engineering includes different approaches for how we can identify what the requirements are for our program and then document those in a way that we're going to be able to actually basically make sure that we've met those requirements. The scale that we're talking about when we're looking at requirements for a program can vary widely just depending on what that program is supposed to do. We might have a program that perhaps it just goes and processes an input file and generates an output file. Maybe it just has one or two requirements. But in a lot of government business applications, you can have huge systems that are designed to go and, for example, state of West Virginia recently implemented a new main computer system. It's going to go through and run finances, inventory, business processes for all of the state government. Something like that can have tens of thousands of requirements. Just the scope can vary a lot depending on what your program is supposed to do. But no matter what size program you're looking at, you need to make sure that you've got a way of figuring out and what exactly you are going to be expecting it to do. Once you've gone and identified the requirements for your software, you've got to design an approach to actually implement those requirements. How are you going to go and write software that will allow you to go and meet those requirements? So there's different strategies in terms of how we can go and design things. that software engineering is going to provide for us. And then the last piece of the puzzle is actually going and taking our design and converting it into a working implementation, going and coding things. Software engineering is going to give us approaches here for how we go and code and test and maintain our software. But there's also different strategies that are going to impact the efficiency of this development process. When we're going and writing code, we have developers, sometimes we have project managers that go along with it. There tends to be a lot of labor that's associated, especially with larger projects. And labor can be pretty costly. So it's really important that we try to efficiently use those human resources that we have available, because they are a finite resource. By going and being smart here with our processes, we can try to make sure that we get the most work done as efficiently as possible. Software engineering gives us different approaches for being able to manage what's known as the software development lifecycle, basically the steps that are actually involved in developing software. Now, the software development lifecycle, depending on who you talk to and where you look at, it can vary slightly in terms of names for different steps, and sometimes some things will break stuff up into more steps, but in general, we're looking at a couple of basic phases here. And you can probably guess most of them from what we were just talking about on the previous slides. The software development lifecycle starts off with figuring out what we want our software to do, going through and defining the requirements that we're going to have for our new program. Once we have our requirements identified, we're going to go and figure out a design for our software and how different components are going to interact to be able to actually create a solution that will meet those requirements that we've identified. Once we've got that designed, we can set about going and implementing it by actually writing code. Then, once we've got stuff coded up, we want to test it to make sure that it actually works as intended, that we get accurate results and our software goes and runs, we don't encounter errors, things like that. Once we've got our solution tested, we need to be able to deploy it so that end users can actually go and access it. And a lot of times this deployment is kind of an ongoing thing. It's not necessarily just that we roll out the software and we're done. There'll often be maintenance associated with it. So being able to go and sometimes just, backups and doing reports and things like that. But a lot of times it may be stuff like going and collecting user feedback, going through and then being able to take information into a new cycle to go and design updates or bug fixes for the software. So the exact, flow here, like I said, you might see slight variances, but this is pretty much what's involved in the software development lifecycle. One of the big parts of the software engineering field is the existence of different models or methodologies for managing the software development lifecycle. We have those different steps that we've identified, but depending on what sort of approach our organization tends to favor and what our goals are, there's different ways that we might actually want to go and divide up those tasks and go and attack them. We're going to take a look at two of the most common models here in a moment. But there's a lot more ones out there if you go and look, and you'll find out about it in later courses, than what I'm going to talk about right now. Different models have different sets of advantages and disadvantages. Some of it kind of relates to what you're trying to do. Some of it is how risk-averse your organization is, or how it tends to go and just manage projects in general. But you're going to see there's kind of two major divisions of thought here. And they're going to relate to how important is it that you go and put out software that is reliable, because you can either go through and have software that you're sure is, rock solid and it does everything that you want and it does it correctly, but that's going to take a long time. So you might have a long period between software releases. There's another sort of field way of thinking on things here that, we want to try to have software be reliable. We want to try to test things, but, we can go and always put out a new version if there's a bug that we find. So you can kind of have an emphasis on rapid releases, where you're going to go through and just, if you get a little bit of new functionality, you go and release it. If there's a bug that comes up, you just go and put a fix out for it. It's not necessarily as stable of a platform as you might see with the other approach. And one of the big differences between these two approaches here is how they handle flexibility as needs change for the software. On one end of the spectrum, we have what's called the waterfall software development model. And waterfall is kind of the traditional approach that you would see used out there. And it still tends to be favored a lot by government projects and with large businesses. Waterfall basically says that you have a whole sequence of things with those different steps that we were talking about for the software development lifecycle, and you go and finish up one step before you go and move on to the next one. So with this, you go and do all your planning with identifying your requirements up front, and then you go and work out an entire design for your software, and you get that all done before you go into work on implementing it. And then once you've got a full implementation, then you can go and start to test it and then look at deploying it here. The idea is basically you're doing one thing at a time, and you're going to generally kind of end up with sort of a monolithic, one big package approach for your software here. And that's what you're going to go and deploy at the end. The waterfall model has some noticeable advantages for things here. One of the biggest things is that it tends to be really well documented. With the waterfall model, you're going to have at the outset a set of requirements and a fully featured design, generally speaking, as most places going to approach this, so that you know exactly what you're going to be doing as you go and code. Since you're going through and working out all this stuff ahead of time, you can put a lot of thought and effort into making sure that the different pieces go and fit well together, because you're kind of planning everything at one stage. You know this is everything we're going to expect this program to go and do, so it becomes easy to go through and figure out how those different parts are going to have to interface with each other. And the fact that we're going through and doing this all at one time here, we're doing all this planning and all this work up front, that does take time, but once we actually start to go and implement things, it means that we've probably answered all of our questions. We don't have to go and make a whole lot of adjustments, because we should have identified that all at the very upfront stage here, where we're going and identifying our requirements and then designing things. We shouldn't have any surprises that come on later. All that planning up front, though, does come at a cost. And that means that it can be kind of hard to make changes once you get going with things. If there's stuff that you've realized that you've left out, it can be hard to go through and adapt to include it later, because you kind of have a lot of inertia towards moving on with what we have and going on to the next stage. Everything is kind of set up just to go and continue through the whole process till the end. If there's some other feature that you realize that you need, you might not necessarily be able to incorporate it. Another problem that tends to come up with the waterfall model is that since we're going and testing things towards the end, and then also getting a lot of times feedback from end users, towards the end of the process there, is that we can end up with software that maybe doesn't quite do what we were thinking it was going to do. Hopefully we've identified our requirements, but sometimes there can be a little bit of a mismatch between what we go and document as a requirement and what the end users were really thinking stuff was going to be like. And we can be, well into development with large systems, sometimes years into development, before we kind of discover that, well, maybe this wasn't exactly what we were thinking. This can sometimes lead to really spectacular failures of large-scale projects that go and use the waterfall model. This is really a case with you're doing what's sometimes called ERP, or enterprise resource planning systems, that you'll see a lot of large corporations and governments use. These sorts of systems are huge examples of waterfall planning. You're going to have, like the West Virginia example that I mentioned, they can cost hundreds of millions of dollars and take many years to roll out. And sometimes, just because of their scale, things just start to not quite come together as expected, or things just tend to drag on, and then these programs sometimes will either have costs that escalate, or sometimes they just don't get done. This is one concern. If this goes well, if you've done all your work up front correctly, this model can work really well. But if there's problems with doing that prep work, waterfall can really fall apart. On the other end of the spectrum, we have what's known as agile development. And agile development is really kind of a hot thing nowadays in the IT world. But the idea with agile development is that rather than going and having this long, drawn-out process like we do with the waterfall model, we're going to go and focus on smaller pieces of our overall project, and we're going to try to iterate quickly. Generally, sometimes looking in terms of weeks or months rather than what you might see years with a waterfall model for a larger project here. Agile is used really commonly in development of web apps and also phone apps, so things for like iOS or Android. Kind of the hallmark of them is that there are a lot of releases, because you're going to go through, maybe implement one new feature, and then you go and release that feature. Or you go and do one part of a larger program and you go and release that. A lot of times what you'll also go through and see here is that you may end up with releases that are designed to go and fix other releases. Because you're doing a rapid cycle here for things, where you go and work on one little piece, you're trying to push stuff out the door pretty quickly, sometimes you'll see that there's kind of the idea that, well, if there's something that we've broken, we'll just go and put out a new release to go and fix it, because we'll know that there'll be another release out here in a week or two, versus a case where stuff might drag on for years. Pros and cons for this model here. By going through and focusing on smaller pieces of a larger project, we can go and start getting those into service, which means users can start benefiting from those. So, maybe we don't have quite all the functionality baked in right at the get-go, but maybe we have at least some basic stuff there that will be helpful to people, and we can go and put out additional releases that go and add additional features. Since we can get users exposed to our program pretty quickly with Agile, if there's problems in terms of stuff not working as expected, or maybe just interface design issues or whatever, we can generally go and find those out pretty quickly and go and fix them. So this is something that you're going to see where it's going to give you feedback pretty quickly. It does have some negatives though. One big problem that a lot of times you'll see with Agile, and this is where sometimes people's Agile implementations kind of fall down because they don't do this, is just that you have to put a lot of effort into going through and testing things. You're doing constant releases, so you need to be constantly testing your software as you go and do all this new development on the individual components to make sure everything goes and works together when you go and put it together. A lot of times, since you're also going and adding additional features and things that maybe weren't originally built or designed into the overarching system, you might have to go and rework parts of your program. So maybe rather than building a module once, you might be doing smaller pieces of it, but maybe you end up, if you were to combine everything, kind of building it a couple times, just because you have all these different little changes that you have to keep working in and going through and getting stuff to play nicely with each other. Agile software can be a little bit trickier for IT shops, especially to go and manage. A lot of organizations are kind of built around the idea that we'll get this new version of the software, we're going to go and test it and deploy it to our systems, and that works out fine if you get stuff maybe once a year or twice a year. When you have things that are coming out all the time, like what a lot of times you see with Agile development, that can be hard for organizations to go and just kind of adapt that sort of schedule. It can also be confusing for users if stuff goes and changes a lot. Maybe a good example of that would be with the Zoom video conferencing application, its desktop client. Especially during the height of the COVID pandemic, they were pushing out new versions all the time, and they were going, and really a good example of agile development here, they're making iterations on, adding new features with each of these, sometimes going and fixing bugs, going and addressing user interface issues. They're making improvements, but it's also kind of confusing as an end user because things would go and move around inside of the application. Different settings would go to different places. There'd be new buttons that would come and go. Going through and having constant changes can be confusing for people. Agile is probably, I'm going to say, the most common model that you'll see in use today between Agile, and there's some variations on it like Scrum, where you have more kind of fixed time periods when you go and do releases for things. One thing that has started to become common is that sometimes some older projects that used to be built around a waterfall type model have been migrating more towards Agile. Microsoft has done this with a lot of their software. So for example, it used to be in the past that you would see a new version of Microsoft Office come out about every 3 years on average. There'd be some bug fix releases in between, but you wouldn't see new functionality introduced. You'd have to go wait until, from Office 2013 to 2016 to 2019 for new features to come out. Microsoft has moved to more of an agile approach with Office 365, where there are monthly releases. Sometimes they're bug fixes, but a lot of times there'll also be new features baked into those monthly releases. It's kind of an approach that I think more organizations are starting to get used to, is this idea of basically constant development for things, but it is something that is kind of challenging to manage, and something that as you get into the workforce as a CS programmer, if you do go with that career path, you'll kind of see you're going to have to use and adapt to. But that's something that's going to be talked about a lot more once you get into CS 230. For our purposes here in CS 111, we're basically going to go and kind of follow the waterfall model. We're going to try to plan out what we want to do ahead of time, and then we're going to work on implementing that. Most of our stuff is going to be pretty small scale here, so the waterfall model tends to work out pretty well because we can just sit down and work it all out ahead of time, and it's not going to be a case where it's really going to slow us down having to do that planning ahead of time. Now that we've talked a little bit about some approaches for going and developing software, let's see how we can put things into practice here. We're going to start off with the beginning of the software development life cycle by going and identifying the requirements for our program. Our goal here is basically to figure out what exactly our completed project needs to be able to do. We want to go and essentially build a checklist that we can go and compare what we've coded up against to make sure that we're doing everything that it's supposed to do. The people who know best for this are generally going to be the end users of the intended program. They're going to be the people who are going to be interacting with it on a day-to-day basis, so they're generally going to have a pretty good idea, perhaps with some management input, about what exactly it's going to have to do. There's a couple different ways that we can go about getting that input. The traditional way is to essentially have what's called a requirements list, or sometimes a requirements contract. And basically these are just line items that say, this program will do this. And you will have just a whole ton of these different items here. Sometimes what you can see is that maybe you'll have higher level tasks that you can then go and break down into low level ones, but more detail is better here because that gives us something very specific that we can go and compare against. One shortcoming of this process, though, if we're going through just using lists, is it's not necessarily always obvious from a list how the end users are really intending everything to go and fit together. You might go through and implement a solution that goes and does everything that's listed, but maybe it does it in kind of a disjointed way that just doesn't work out well with the workflow or process that your end users go and normally would want to use. For that reason, there's kind of been a shift lately towards gathering data through user stories. And this is a really common approach that's used in agile development. Basically, you kind of have a conversation with users. You ask them to sort of tell you, kind of like in a paragraph narrative form, what exactly they're expecting to use the software for and what they want it to operate and do. By going through and getting things in plain language, you can a lot of times get maybe a little bit better understanding of how exactly the users see everything kind of fitting together. And then you can go and take those stories and then go and convert those into your list of requirements. But you also have from that hopefully a little bit better idea of what the ideas are for how it should operate. So this is something that you start to see used a lot more now. Bigger organizations, a lot of times, if they're going to go through and hire a company to go and do their development for them, still will tend to rely on requirements lists a lot of the times, and mostly just because that gives an easy benchmark to go and check off whether it was completed or not. You don't have this concern when you're going and dealing with a contractor of differences in interpretation. As an example of some requirements that we might gather, let's say that at a high level we want to create a program to go and track air travel statistics. And we want to be able to gather data on airports, airlines, flights, and individual airplanes for this. That's kind of a good high-level description of what we're trying to do, but there really isn't anything in that description that's readily measurable. There's not benchmarks that we can go and compare against or things that we can go and mark off on a checklist. So we want to go and take a look at a little bit lower level here. Let's go and see how we can break this apart. Well, and these would be things that maybe we would even break apart into separate bullet points, but for slide space reasons here, I'm kind of combining some of these bullet points. We're going to say that we want to be able to create, modify, and delete airports, airplanes, and airlines. So we need to be able to modify and control that data that we've got. We want to be able to create, reschedule, or cancel flights. Okay. We need to be able to go and assign airplanes to specific flights that they're going to be flying. And we want to have flights depart and land so that we can go and keep track of their times for that. Now, this can kind of lead to a case of maybe we have a requirement and maybe there's something associated with it that hasn't been specifically identified and we need to think about. So, for example, it's rare, but sometimes planes do crash. What happens if that flight crashes? What do we want to do? Is that something that we need to have our program address? So just because you have a list of requirements, you shouldn't necessarily take that as the absolute list. There may be other things that, just kind of realistically thinking through things, you might need to address as a sort of an outcome of one of those other items. So be aware of that as you're going and formulating what exactly your program is supposed to do. Sometimes this might be going back to your users and getting a little bit more detailed answers to questions in order to figure out that. Once we've gone and gathered all the requirements for our software, we're ready to start thinking about the design. And our goal here is going to be come up with a design solution that's going to check all the boxes. We want to make sure that we implement all of the requirements. A good way to go and start our design here is to figure out what specific objects the requirements are talking about. What sort of things are we going to need to model in our code? And these are generally going to be what we're going to want as at least an initial set of classes that we're going to go and implement in our program. Classes are designed to go and model different objects. So if we have specific real-world concrete objects that are coming up in our requirements, we probably want to think about going and creating classes to go and represent those objects. If we go back to our flight data system example, we said that we need to be able to track information for airlines, airports, flights, and airplanes. So we probably want to go and model each of those as their own separate class. And that's in fact what we're going to be doing. For each of the different objects that we're trying to model, each of our classes, we need to figure out what sort of data we need to store with them. And at this point, we're really interested in data that might be accessed by other classes or by the user. So we're kind of looking for publicly available data that we're going to be going through and getting and setting in individual instances of this class. If it's stuff that we're just using internally for calculations and things like that, we don't need to really be concerned about that. We're going to deal with that later. This is also a good time for us to think about not only what specific pieces of data we're going to be working with, but what types of data they're going to be represented as. So are we dealing with yes, no, Boolean type values? Are we dealing with integers? Are we dealing with floating point numbers? Are we going to go through and work with strings? Or are they going to be instances of other things? Maybe that we'll be dealing with storing instances of specific classes that represent our other objects inside of these objects. If we go and look at our flight data example, we identified earlier that we had 4 classes, and then we can kind of sit down and think through, okay, what pieces of data do we need to have based off of our knowledge of these objects, and ideally these are things that are going to be laid out in our requirements. So for example, for our airline, we need to have the airline name, and we know that airlines have an abbreviation of code that go with them, the IATA code. So we're going to want that. Same thing goes for airports. We're going to have the name of the airport and its IATA code. For planes, we're going to need to know what airline owns them and what the registration number is for that plane. So most of those so far have been pretty simple. The flight is where things get a little bit more complicated. So we said we wanted to be able to, create flights, so that'll be create a new instance. To cancel, we can just get rid of that instance, but we need to be able to go and reschedule flights. So we need to have, for example, when the flight is supposed to depart and where it's supposed to arrive, time-wise, and from location. So we've got a scheduled departure time, scheduled arrival time, and then a departure airport and an arrival airport. We need to know what airline goes and operates that flight and what the flight number is. So these are things that we're probably going to want to make sure are documented all in our requirements. Even though, they weren't specifically in our list, we kind of inferred their existence. If this was a real world project, we'd want to make sure that we really had these all completely laid out. We said that we also want to be able to track the status of the flight when it goes and departs and when it arrives. So in addition to our scheduled departure and arrival times, we'll have data for the actual departure and arrival times. Looking at the pieces of data that we've identified and our requirements list, we want to think about what methods we want to make available for each of our classes. And again, we're looking at methods that would have like a public access modifier on them. We're looking at things that are going to be used outside that class right now. Since we have data pieces, a good place for us to go and start here is to figure out how do we want to access that data that we've defined. Are we going to go and allow direct access to those fields, which sometimes is done, or are we going to go and provide getter and setter methods to go and be able to manipulate and retrieve those values? That's a very common approach that allows you some control over what's actually being stored, and it can give you more flexibility for things. So, is that something that we want to go and do? Outside of the getters and setters, maybe there's other actions that we need to go and perform that are going to be related to that data. If we have a flight, we're going to have it take off, and we need to record the time that it goes and takes off. So those can be some other things that, perhaps not quite a getter and setter, at least in terms of the name, but they're going to be manipulating our data. For each of the methods that we identify, we need to figure out 2 things. What input it's going to take. So are there any parameters or arguments that we're going to pass when we go and call that method? And if that method is going to go through and return anything. So if we're just doing, for example, a setter method, we're going to go through and take the value we're supposed to set as an input parameter, and maybe we don't return anything, maybe we do a void, or maybe we return like a true or false if it was successfully set. You're going to have to figure this out for each of the methods that you're going to have. In terms of common methods that you might want to think about, in addition to some of the getters and setters here, you might want to go through and take a look at if there's common output formats that you might need to have. Maybe it's implementing a toString method. If there's different calculations you want to do based on the data. Some use case that you might see sometimes for setters is if you want to make sure that specific things happen when you go and update values. Maybe you're doing some sort of validation check, or there's other related records that you're going to have to go through and adjust. Different things, you kind of want to map out what exactly you need to have happen with these objects. And this is something that you should be able to figure out from the requirements for this program. In the case of our flight data system, a lot of the methods that we're going to have will be simple getters and setters for manipulating the data that we're going to store as part of these objects. So like with our airlines, we're going to have get name, get code, set name, set code. And that's pretty much the case for our three simplest classes, airline, airport, and airplane. Although there are some enhancements. For example, in the airline class, I've designed methods to go and get all the airplanes that are associated with that airline, and to get all the flights that are associated with that airline. And we can return those as a collection, like an array list. Things get a little bit more interesting over in our flight class. In part, we have more fields there, so there's more getters and setters to go and configure. But we also have some methods here that aren't necessarily traditional getters and setters. For example, we have this record departure method, and we have record arrival. These are going to go through and manipulate data that we have stored. It's going to be the actual time that the flight departed and the actual time that it arrived. But we're not taking any input parameters. We're just going to go through and figure out the departure and arrival based on just the time that this method was called. It's pretty common that you'll have, set of getters and setters, and then you're going to go through and have some ways that you're going through and augmenting it with additional methods to go and manipulate that data as well. Once we've finished figuring out what methods we're going to provide for each class, we want to double back and consider the data fields that we identified. And we need to figure out if those are fields that we're going to make accessible directly to outside of the class, or if we're only going to allow access through getters and setters. Basically, what we're going to do here is we're going to take our methods that we've defined and any fields that we want to allow direct access to, and we're going to essentially make those be the interface that our class is going to present to the rest of our code here. You probably have heard of APIs, or application programming interfaces. Those are the publicly available methods and fields that are out there with classes for other code to go and interact with. Now, we can have sort of the API, the interface to our class, and we can do that as a class. Depending on the scope of what we're trying to do with our program and potential needs for flexibility down the line, sometimes what we can actually do is spin off those into what's called an interface within Java. And other languages have similar concepts. C# has interfaces too. But basically, an interface is kind of not an actual implementation of all those methods, but it's a listing that classes that go and implement this interface will provide these methods and these fields. So you can go and create an interface, and then you can potentially have multiple different implementations with different classes that go and implement that interface. And that can sometimes buy you a little bit more flexibility with how you're going to go and use things. But it's really kind of a case that's going to depend on what you're specifically trying to do with your program and trying to figure out whether interfaces make sense or not. It's kind of beyond the scope of what we're trying to do with today's lecture. So just kind of be aware of something that you might want to go and look at more if you haven't worked with interfaces before. An important part of the design process is going and documenting our design. So once you've gone through and figured out what classes and interfaces and all you're going to go and provide, you need to go and have some sort of record with that. There's different ways that you can go and do that. One approach is to just go and create lists, kind of like what we've done on these slides here with our flight status example, where we're going to say we're going to have this class and it's going to have these fields and it's going to have this set of methods. That's one way you can go and do things. And if you have a fairly small project, that's not necessarily a bad approach to take. As you get into larger programs, though, you can end up with, dozens or sometimes hundreds of classes. And just having lists of things, it's not always going to be obvious how everything is supposed to go and fit together. That's when you're going to start to see more of a benefit from going into a modeling language like UML, Unified Modeling Language. And this is something that CS230 will cover a lot more. But these allow you to sort of visually represent what the different parts of your program are, the different objects and classes that you're going to have, and how they're all going to tie together. So as you get into larger scale projects, kind of the need for stepping up your documentation tends to increase just because it's harder to understand everything because there's more of it, and also you're going to tend to have more people having input and working with that project. Once we have our design worked out, we're ready to start implementing it. This is where we're going to actually write the code to go and turn our design into actual real code with instantiable classes that we can go and put together to have a running program. Now, a lot of times people will think, well, I'm done with design, so let's just start cranking out code. And that's not necessarily a good strategy here. You want to continue to be thoughtful in the design of your program. Even though you kind of have the basics of how things are going to work based off of the different fields and methods that you've identified for your classes and any interfaces that you want to have, there's more pieces to your program. You're probably going to have helper methods and other values that you're going to use to kind of glue and spin off certain subtasks of what your work is. You want to be thoughtful about how you go and set those up too. So don't just figure that you're ready to start foregoing any more planning. You should still be thoughtful, take time to go and sketch out how things are going to work here. Even if it's not necessarily going to be quite as critical for documenting things, because this is all going to be stuff that will be internal, private methods and things within your class, doesn't mean you want to go and skimp on planning. A big part of the implementation of a program is figuring out how we're actually going to go about implementing our solution. This is something that's going to vary depending on the size of the project that you're working with. For smaller programs like we'll be dealing with here in CS111, where you don't have a whole lot of code to write and it's just one developer, probably makes sense for you to just go and kind of do everything more or less together. Maybe you go and write up one class, you go right at the next class. Maybe you're doing a little bit of back and forth work between the classes. But as you get into larger projects, that tends to not scale well. If you end up with many classes, it can be hard to go and kind of work back and forth and tie them together. Or maybe you have multiple developers and you need to have some way to divide the workload up. When you get into larger projects, you tend to see that there is some sort of dividing the work into multiple different units of related aspects of the program. And a lot of times those might be farmed out to different users. This can happen even if you're going and doing a waterfall type model. Going through and breaking up things into small pieces is definitely a hallmark of agile development. But even with waterfall development, where you're doing everything in one big phase, you can have, while everybody's on the implementation phase, multiple teams going and working on that. So it's just going to kind of depend on what sort of approach you're taking and the size of what project you're dealing with as to what makes sense. There's not necessarily a one-size-fits-all answer for this. Traditionally with software development, we would go and implement a solution, and then once we've gone and implemented that solution, we're going to go through and have a testing process for that. We want to make sure that we're thorough with our testing, that we A, hit all of our checklist of items from the requirements, but B, make sure that our program actually does what it's supposed to do and doesn't encounter errors during normal running. We want to make sure that we have some sort of standardized process for testing. And this can involve design work too. We don't just kind of want to do ad hoc, just try throwing values at things. We want to actually have a standard checklist of items that we're going to go through and test. And we want to make sure that we go and follow those consistently. One approach to going through and making sure that we have consistent checklist of items that we're testing are to go and write unit tests. With unit tests, we can automate the testing. What we're going to do is go and set up coded examples here where we're going to provide input, a particular input value to a method that we have, and we're going to go and check the results that we get back from it. And we're going to make sure that they match what we know and have manually coded to be the correct answer. Traditionally, what you've seen is that people will go and kind of do the unit tests on the back end to go and make sure that things work, or whatever testing strategy they do, it happens after the fact. Nowadays, there's been more of a shift towards test-driven development. With test-driven development, you actually go through and write the tests ahead of time before you go and write your code. So you'll go and generally key your tests off of the requirements that you've identified for this program. And you have these unit tests set up, you go and write code, and you're continually going through and running your code against those unit tests. And assuming that you're thorough enough with your unit tests in documenting all the different circumstances that can have, the idea here is that you keep coding until you go through and check off and get passes on all of your unit tests. That's how you know when you've gone and implemented everything. So that's a newer model, and depending on what sort of project you're working on, that can be a good approach to things, especially if you have a large team. Just going through and having a big set of unit tests, that way you're making sure that everybody's kind of on the same page and checking against the same list of things as they go and write their code. That can be a very effective approach. The last part of the development process is going through and getting our software out to end users. So after we've tested things, we're comfortable that our software works and correctly and does what it needs to do, this is when we're going to go and push out a release of our software. And a lot of times deployment is not necessarily just a once and done thing here. You might go and put out a version of it, but you need to have some sort of maintenance that's going on with that software too. You can have bug fixes that you have to go and release. Maybe you need to go through and manage backups and things of that software. Maybe you're going to maintain the infrastructure that goes along with running that software. So deployment maintenance, sometimes are seen as separate phases, sometimes they're kind of merged together, but just be aware these can be an ongoing thing. Just because you go and finish writing code doesn't necessarily mean you're done with a program. This lecture has an accompanying participation assessment that you'll need to complete in eCampus. It has 4 questions, and you'll have 10 minutes to do it. You need to work by yourself, and you may use any of the resources that I've provided with the slides, this video. You can also use a textbook and any notes that you've taken, as well as sample code that I've provided. You cannot use the internet or anything else. That's where we're going to end things for this brief look at the software development lifecycle. If you have any questions, please join the Q&A session or send me an email. Thanks, and have a great day.